Welcome, builders and future engineers. Today, we're unlocking the language of engineering drawings. You might have a brilliant idea, but if you can't communicate it clearly, it stays stuck in your head. Engineering drawings are the universal language that turns ideas into reality. But here's the catch. This language has two main dialects, first angle and third angle projection. Think of them as two ways to unfold a 3D object onto paper. Mix them up, and you're in trouble. Parts get made backward, holes end up in the wrong place, and your project stalls. My goal is to break this down so anyone can understand the difference. We'll see what these projections are, how to tell them apart, and why it matters. By the end, you'll spot the difference between first and third angle projection instantly. Let's get started. Before we dive into the details of first and third angle projection, let's take a step back and understand the foundation they're built on. Orthographic projection. Orthographic projection might sound like a complex term, but it's actually a straightforward concept. It's the method we use to represent a three-dimensional object using a series of flat, two-dimensional views. Think of it as a way to unfold a 3D object onto paper, so every detail is clear and nothing is left to guesswork. It's like translating a real-world object into a language that engineers and builders can universally understand. For example, picture a coffee mug. If you look at it from the front, you'll see the handle sticking out to one side. Now, imagine looking straight down from above. All you see is a circle, the rim of the mug. From the side, you get a profile view, showing the mug's height and the handle's position. Each of these views is drawn straight on, without any perspective or distortion. No vanishing points, just the true shape and size of each part. This approach eliminates any ambiguity, which is absolutely essential when you need to manufacture or construct something with precision. Take a simple wooden block as another example. By drawing its front, top, and right side views, you capture every important detail about its shape and dimensions. With just these three views, anyone, anywhere in the world, can understand exactly what the object looks like and how big it is. Orthographic projection is the backbone of technical drawings, whether you're designing a skyscraper, a car engine, or a tiny mechanical part. The real magic lies in how these views are perfectly aligned. Width, height, and depth all match up across the different views, making it easy to cross-reference details. But here's the catch. How do you decide where to place each view on the paper so that everything makes sense? That's where first angle and third angle projection systems come into play. They're the rules that tell us how to arrange these views. Mastering this arrangement means you'll be able to read and interpret any technical drawing with total confidence, no matter where it was made. So, let's break down how each system works and see why this knowledge is so important for anyone working with technical drawings. First up, let's talk about first angle projection, a method that's fundamental to technical drawing and engineering design. This is the standard approach used throughout most of Europe and Asia, forming the backbone of how engineers communicate complex shapes and ideas. Imagine you have an object, and you're placing it in front of a set of transparent drawing planes, almost like setting it on stage in front of a glass wall. You look through the object, projecting its silhouette or outline onto the plane that's behind it, capturing its features from your viewpoint. The front view, which is often the most informative, sits right in the center of your drawing, acting as the anchor for all other views. To get the top view, you'd naturally look down from above. But here's the twist. In first angle projection, you actually draw that top view below the front view, not above it. It's a bit of a mental flip. Your eyes are looking from the top, but your pencil puts the image on the bottom of the page. This can feel counterintuitive at first. For the right side view, you stand on the right side of the object, but in your drawing, you place that view to the left of the front view. Similarly, the left side view is drawn to the right of the front view, maintaining this opposite side placement. And if you want to show the bottom of the object, you draw that view above the front view. flipping the expected positions. In essence, every view is projected onto the side opposite to where you're looking from, creating a mirrored layout of perspectives. Think of it like unfolding a box with the object inside. Each face of the box becomes a panel on your drawing, and the images are pushed outward onto those panels. This system might take a little getting used to, especially if you're more familiar with other projection methods, but it's incredibly consistent once you grasp the logic. Always remember, in first angle projection, the views are placed on the opposite side from where you're observing. This is the key to reading and creating these drawings correctly. Millions of engineers, designers, and drafters rely on this system every single day to ensure their ideas are communicated clearly and accurately across borders and industries. Now that you understand the European way, let's see how the American system compares and what makes it different. Now, third angle projection, the standard in the US, Canada, and Australia. Imagine the object inside a glass box. You're outside looking in. The front view is central. Look down for the top view and draw it above the front view. The right side view is drawn to the right, left side to the left, and the bottom view below. The views are placed exactly where you look from. No mental flips. It's straightforward. What you see is where you draw it. This makes third angle intuitive for many. Both systems achieve the same goal, just with different arrangements. Let's learn how to spot which system a drawing uses. When you're handed a technical drawing, one of the first questions you should ask yourself is, how do you know which projection system the drawing uses? This is absolutely crucial, because interpreting the drawing with the wrong projection system can lead to major errors down the line. The answer lies in the title block. Always look for the projection symbol there. It's your first clue and the most reliable indicator. The symbol you're searching for looks like a truncated cone. Imagine a lampshade displayed in both front and side views. This simple shape carries a lot of meaning in the world of engineering graphics. For first angle projection, you'll notice that the circular side view is placed to the left of the trapezoidal front view. This arrangement is a visual shorthand for the projection method used. In contrast, for third angle projection, the circles are positioned to the right of the trapezoid. This subtle difference is easy to overlook, but it's absolutely vital. This matches the fundamental rule. In third angle, the view is placed on the same side as you look from. In first angle, it's the opposite. Understanding this rule will help you visualize objects correctly from the drawings. Take the time to memorize these symbols. They're your key to unlocking the meaning of any technical drawing, no matter where it comes from. Before you start interpreting any drawing, always check the title block for the projection symbol. It's a small step, but it can save you from big headaches later. This tiny symbol might seem insignificant, but it makes all the difference between a correct interpretation and a costly mistake. If you get this right, you'll avoid confusion, wasted time, and expensive errors. Double-checking the symbol is a habit every good engineer develops. Think of the projection symbol as your Rosetta Stone for technical drawings. Never guess, always confirm before you proceed. Now that you know how to identify the system, let's talk about when and why you'd use each projection method. Which system is better? It's not about better, it's about your audience. Third angle is standard in the US, Canada, Australia, and Japan. First angle is standard in Europe, the UK, and most of Asia. Always match your drawing to your client's or manufacturer's expectations. Using the wrong system causes confusion, delays, and expensive mistakes. When in doubt, ask your client or partner which standard to use. Communication is key. Confirm before you start. Adapt to your audience and you'll avoid headaches. The most important rule, never mix first and third angle projections on the same drawing. Mixing systems creates confusion and guarantees errors. If you draw the top view above the front, third angle, but the right side view to the left, first angle, no one will know what you mean. Consistency is critical. Use one system for the entire project. Set your CAD software to the correct standard from the start. Every drawing, every part must follow the same projection. This keeps your design communication clear and error-free. Be deliberate, be consistent, and never mix your projections. Let's wrap up with some tips. Always check the projection symbol first. It's your map. Practice by sketching simple objects from different angles, using both systems. Hands-on drawing builds your mental model. Don't hesitate to ask questions if you're unsure. Clarity beats costly mistakes. Be patient. Mastery comes with practice. Learn from your errors and keep improving. Consistency and attention to detail make you a better engineer. Now go build something amazing. You've got this.